Section 6.5 is the graph of tangent, cotangent, secant, and cosecant. I would pause the video and write down these notes real quick. So first we're going to look at tangent and cotangent. So if you remember from earlier sections, the domain of tangent is that x cannot equal pi over 2 plus k pi, where k is an integer. So basically at the top and the bottom of the unit circle, pi over 2, 3 pi over 2, negative pi over 2, so on and so forth. So what that means is at those spots we actually have vertical asymptotes. So every time you have a pi over 2, you have a vertical asymptote. This is because at the pi over 2's, your tangent, remember, is your y-coordinate divided by your x-coordinate, and those are where your x-coordinates are 0, and you cannot divide by 0. So at negative pi over 2, 3 pi over 2, we have vertical asymptotes. So if we plug in some other points on our table here, I picked negative pi over 4, 0, and pi over 4. So these are our angles that we're plugging in here. If we plug in negative pi over 4, we get negative root 2 over 2 divided by root 2 over 2. So that's a negative 1 for tangent. If we plug in angle of 0, we get 0 divided by 1, which is 0. And if we plug in pi over 4, we get root 2 over 2 divided by root 2 over 2, so that's a 1. So this is what the graph of tangent of x looks like. And then if we go back and plug in 3 pi over 4, you end up with a root 2 over 2 divided by negative root 2 over 2, so you end up with a negative 1 again, and it repeats. So just like sine and cosine are periodic, so are tangent, cotangent, secant, and cosecant. The difference is for tangent and cotangent, the period is only pi. Every pi it repeats. This is because they're ratios of the x and y coordinates, and so when you pass halfway through, it's going to repeat itself. So now let's look at cotangent. If you remember from the earlier notes, the domain of cotangent, the ratio is x divided by y, so your y coordinate can't equal 0, and that occurs at all the integer values of pi. So our domain of cotangent is that x cannot equal any integer value of pi. So the way this translates to our graph is we're going to have vertical asymptotes at all the integer values of pi. So for instance, negative pi, 0, and pi. To make a table, we have vertical asymptotes at negative pi and 0, and then pi and 2 pi and so on and so forth. If we plug in negative 3 pi over 4, remember, cotangent is x over y, so you'd get negative root 2 over 2 divided by negative root 2 over 2, so you get a positive 1. If I plug in negative pi over 2, that's the same thing as positive 3 pi over 2, I'd get a 0 divided by 1, so that's a 0. If I plug in negative pi over 4, that's the same thing as 7 pi over 4, so you get root 2 over 2 divided by negative root 2 over 2, so you get a negative 1, and then it's going to repeat. This is going to be a 1, and this is going to be a 0, so on and so forth. So if we graph it, you end up with a 1, 0, negative 1, and then it continues to repeat the same thing every pi distance. Again, your period for a cotangent is also pi. So now go ahead and graph this tangent function, y equals negative tangent of 2x plus pi over 2, using your transformations. First, you're going to want to find your period and your phase shift. Make sure you factor out this 2 first so you can get an accurate phase shift. So in this one, you have a reflection across the x-axis. You have a period of pi divided by omega. In this case, omega is 2. So your period has been shrunk in half. It's now pi over 2 instead of pi. And if you factor out this 2, you end up with a phase shift pi over 4 to the left. So instead of starting low, like a normal tangent graph, because of the negative out in front, it's going to start high. And the over 2 shrunk our period in half. So instead of going from negative pi over 2 to pi over 2, it went from negative pi over 4 to pi over 4. But then we shifted everything to the left pi over 4. So one period goes from negative pi over 2 to 0. So this is one period. A lot of times the question will ask you to graph one period or 2 periods. So if it asked you just to graph one period, any of these would have been a perfectly good answer. If it asked you to graph 2, then you would have wanted 2 consecutive ones like that. So here are the graphs of secant of x and cosecant of x. So remember, secant of x has the same domain as tangent of x, where you can't be any of the multiples of pi over 2. So just like tangent of x, you're going to have vertical asymptotes at those points. For cosecant of x, you have the same domain as cotangent. You can't be multiples of pi, so you're going to have vertical asymptotes at those points. And then they're kind of like little parabolas inside each of those. Two sets of vertical asymptotes is 1 period. So 1 period, just like sine and cosine, is 2 pi for both of these functions. If you were to graph the cosine of x in the same graph as the secant of x, what you'll notice is it actually is the inside of the function. So this green function is the cosine of x, and it kind of follows similar points but is in the opposite direction as secant of x because of that reciprocal relationship. Similarly with sine of x, if you graph the sine of x inside secant of x, you'll see this opposite reciprocal relationship of the graphs as well because of the reciprocal functions. Just like sine and cosine, the period for secant and cosecant is 2 pi divided by whatever omega is. You can have a phase shift just like the other functions. You could have an a out in front that would just denote how high or low these points start, these little parabolas start and end. Otherwise, the graphing is very similar to the other functions, just with a different parent function. So these are 4 new parent functions that you're going to have to know and be able to do your transformations on. So make sure you know where all the asymptote lines fall. And that really is kind of the point, the starting point for graphing these 4 trig functions.